Hello everyone, welcome to the first experiment in electronics lab. Today we will learn about diode characteristics. All we will do today is just construct this circuit. Simply we need to connect a diode, this is the diode name, in forward bias mode. Connect a current limiting resistor in series with the diode. So we need one resistor in series with that diode. Slowly we will increase the voltage applied. This is the voltage source. We will increase it slowly from 0 to 15. And then we will measure the current through the diode and the voltage across the diode. Take more than 10 readings. We will use this table to put the measured values. Here is the VD, which is the voltage across the diode, and ID, the current through the diode, and VR, which is the voltage across the resistor. Then we will need to plot the VD and ID graph, and from this graph we can calculate the forward resistance by the calculation of the slope of the curve on the on region. First, let us construct this circuit using multisim. This is the software that we will work on. If you have difficulty with downloading it, you can email me so I can help you. So, let us start constructing the circuit. First, we need a voltage source. Right click and then place component. Go to power sources and to DC power. After we place the voltage source, we will need a diode. Again, this is the name of the diode that we will use. So again, right click, place component, go to diodes group, then switching diode, you can find it here, 1N4148. Then we will need a resistor. Again, place component, go to basic, and then resistor, can write here 1 kilo ohm, and place it here. We just need the ground here and connect them. It's better just to rotate this one and connect them. We need ground, we can place component. So go to sources, power sources, and find here ground. Put it here. Now the circuit is ready. You just need to change the value of the voltage source. Start from 0 to 15. Take 10 readings according to the table here. Change the value of the voltage source. Let's start from 0.1. Now we need to measure the voltage across the diode, so we can use one of these tools. Put the positive side here and the negative side here, and you can simply run it. You will see the voltage across the diode. It's 100 millivolt. And measure also, you can measure the current through the diode. You can put it here and run it. You will get this value 4.78 pico ampere. And just like that, you can measure the voltage across the resistor, and you can read the voltage across the resistor is 4.78 nanovolt. Now all you need to do is just change the value of the voltage supply, make it 0.2. Again, read the values, write down the measured value that you get from here and place it in the table. Keep increasing the voltage source. You can put 0.5. First you need to stop it and put 0.5, run it. Again you will have values here, place them on the table. Keep doing that for 10 different values. After you finish filling this table, you will need to plot it. Plot according to VD and ID. The graph will be something similar to this side only, to the forward side, from 0 to. After you finish, you can calculate the forward resistance depending on the slope of the curve on the on region. The on region is the region where the current is start to increasing significantly. As you can see here, measure the slope over here to find your forward resistance. After you finish, we will do the reverse bias mode. Everything is similar except that we will put the diode on the reverse direction. So let's do that. We will just need to disconnect it and right click, flip it horizontally, then again connect it. Same thing, measure the voltage across the diode and the current through the diode. Take different value of the supply voltage according to table 1.2 and fill it. Also you can then plot it as a graph like this one in the reverse bias mode. And then you can simply answer these questions, and then we will need you to plot the graph in that Word file. Thank you for your listening. That's all for today. Again, if you have any question, you can email me.